Nice about a hand lens, if you're really kind of feeling a little bit of pressure to come up with an answer, it's a great stalling tactic. Because you can be like, let me look at that more closely. And they're going to be really impressed because, you know, you got that Master Gardener badge on. And they're thinking, oh, here's the expert doing close examination. Would y'all like to look at, I never do that. So y'all might. Anybody would like me to pass this around? This is the cell phone attachment.
You trust me, you don't trust me. Look at me like, should I give it to you?
Okay, so we've been through prevent, we're on integrated pest management, we've been through prevent, monitor, assess, and identify, right? No, prevent, monitor, identify, assess. We're on assess, right? And so there's this concept of economic threshold that's used in agriculture. And the idea is that if we're looking at a crop of strawberries or tobacco or soybeans or whatever the case may be, it costs money to spray a pesticide. It costs money for the product. It costs money for the diesel to run the tractor. It costs money for pay the person that's driving the tractor and making the application. And so if your yield loss costs you $10 an acre, but the pesticide spray costs you $20 an acre, you don't spray. I mean, that's the idea of economic threshold. And so one of the messages that we work hard to get across to farmers is to use that concept and that it can increase their profits if they'll follow those integrated pest management strategies and use these economic thresholds. And there's super smart people at NC State that work out what is the actual economic threshold for a given pest in a given crop and develop these monitoring strategies of look at every 10th plant and count or whatever it may be. And we can show them that it saves them money. But you can use the same general concept in your landscape and just looking at a particular issue that you're having and deciding, is it worth spending money on a product and taking the time to read the instructions and mix it properly and make the application, and do I have the right equipment, and all those questions. I have a guy in Warren County, super nice guy. He's got pecan trees, and he's got 8 or 10 pecan trees on his farm. He's a retired farmer, and I don't think he got this message because he went out and bought a $5,000 air blast sprayer so he could spray his pecan trees to control disease, and it was really the only way to control that disease. And he's a great guy. He's super nice, and he knows it was a ridiculous choice, but he loves growing pecans, and he doesn't need the money anyway, so economic threshold, but we can use the same concept in our landscapes when you're looking at a plant and saying, is it worth treating? And if it's the focal point of the landscape, if it's the hydrangea that was taken from the cutting at grandmother's home place, then maybe that's got some value to it. But maybe if it's annual flowers that for $20-30 you can go and replant with something different, then maybe it's not worth it. So just going through that kind of process in your mind. But there's some situations where one pest breaches that economic threshold, and this is an example. Does anybody know what this is? Good guess, but this is not a pine tree, but pine beetle will cause the same symptoms, and it is a beetle. This is the emerald ash borer. Okay. Did y'all learn about that last week? Okay. You learned about borers. Okay. So this is a borer. It's emerald in color, and it gets on ash trees. Hence, they call it the. Okay, so and what it does is it lays its eggs under the bark, and then the eggs hatch out, and the larvae or the grubs, tunnel through and girdle the cambium of the tree, and it kills it. And if an ash tree gets infected, then it dies. Period. So, in this case, economic threshold is kind of a moot point. So, but one small insect on a leaf, maybe that's not economic threshold. And now you're ready, you've gone through that whole process, you've done everything you can to grow a healthy plant, prevent through plant selection, installation, all those other things. You've monitored, catching problems early, and then you've identified and assessed. Now you're ready to select the control measure. And hand removal, great tool. You see insect eggs on the leaf of a cabbage plant or a squash plant. Squish them and you're done with it, right? Bagworms on a Leyland Cypress. Use those, this is a little bag that's about maybe 1.5 inches, 2 inches long. And did y'all talk about these last week?
Yeah.
Okay, so you flip it off or pull it off. At this point, it could potentially have the eggs in it for next year, so getting those off is really helpful. This is a fungal gall on an azalea plant. No need to treat. Just use your hand pruners, clip off that section of the plant, and you're done. Exclusion. Is there some measure I can take to exclude the pest from the site? And so in the case of the cutworms, we can put a little collar around the base of the plant, which prevents that little caterpillar from cutting through there. Maybe we can use row covers over the crop at strategic points in the growing season when that particular insect pest is active to keep them off the plant. So that may be an option in some cases. And then pesticides. So, if there's an alternative to pesticides, by all means, let's use it. And let's make sure that we're getting that message across, is where there's an alternative, let's use it. So pesticides, in my opinion, they should be a last resort. And you should choose the least effective, you should choose the least effective option so you'll buy more plants. Choose the least toxic effective option. And I guess that was it, 2 bullet points. So that's critical. And so here we have, these are both forms of the BT products, Bacillus thuringiensis. Did y'all learn about that last week? It's a, it's the.
It was in the chapter.
It was in the chapter. Okay, so for those of you who haven't read the chapter, which I'm sure is only like 1 or 2 of you, dipel, worm whipper, Thurside. These are all different brand names for BT, and it's manufactured from a bacteria. It's like the protein component or something of a bacteria, and it kills caterpillars, and very effective. I think they have to consume it, and then it messes up their stomach. So, and very low toxicity, and that's what we're looking for, is low toxicity. And just to, again, remember, natural, not necessarily low toxicity. In many cases it is, but you have to be skeptical. Yes?
Is it also quite specific in that it goes for caterpillars and therefore some beneficials won't get harmed?
Yeah, this is fairly specific to caterpillar and beetle grubs. You know, yeah. So,
Is there some kind of subtle way to figure out which is more toxic? Is there a list somewhere, a way to look it up?
I'll give you some tools. Yeah, so let me keep going, and I think I'll answer that, but if I don't, bring it back up. Okay. All right, so I think it's really important for this big picture about pest management to have some basic understanding of how pesticides make it to market. And this is where my 3 years working for that pesticide research organization were really, really invaluable to me in having that broader understanding. And I've also, you know, been to a lot of training in my extension career. I've toured a pesticide research and manufacturing facility, which was fascinating. So, you know, and this is something that the general public has a very poor understanding of. So, first thing to understand is that there is a process for registering pesticides. I am not allowed to go out into my workshop and take various, you know, ingredients and mix them together and put them in a bottle, slap the word, you know, Paul's insect killer on it, and sell it. You have to go through this pesticide registration process through the United States Environmental Protection Agency. So it is regulated, and it's a comprehensive, multi-step process, and it includes, and we'll talk about each of these steps. We go through efficacy, toxicology, environmental fate, ecological effects. If it's something that's going to be used on food, then there's testing to look at residues, and it's a multi-million-dollar process and a lengthy process. I think from someone in the industry, I think the figure was something like, you know, 10 years in $100 million or something like that. I mean, it's not simple. So, and to go through all those studies according to the protocols and everything. So, all right, so again, it starts with efficacy testing, and this is, you know, just answering the question, does it affect a pest? Will it, you know, I've got this new molecule that I've created in the lab. Will it kill a weed? Will it kill the emerald ash borer? So, you know, we can grow the weeds in a greenhouse in a controlled environment and spray the molecule or, you know, the chemical and see is there an effect. Put the insects in a jar, and, you know. So that's the first question. And that alone takes a lot of science and a lot of research. And, you know, it's done in controlled conditions, starting out in the lab, and moving into a greenhouse, you know, sealed environment, pretty strict controls over access and protective equipment and all that kind of stuff. And then they move into the field, and it doesn't actually happen in big, huge fields like this. It happens in these little tiny blocks where, you know, I mean, you know how research works. If it's a product and they're trying to see will it work on, you know, a certain pest on squash, then they'll plant 16, you know, 10 by 10 blocks of squash, and they'll test different rates and leave an untreated, and, you know, it'll be a blind experience. So the people collecting the data don't know which was treated, which was untreated, and all that kind of stuff. So that's the efficacy testing in the field, just trying to get to the question of, does it work on anything? And then we look at toxicology testing, and it's not necessarily, I mean, I don't know that there's a specific order to this, or if there is, I don't know what it is. So some of these things are probably happening simultaneously, but then we're definitely looking at toxicology. Is it harmful to humans? And we're trying to determine, is it going to make you sick? And we're looking at acute effects. So if this gets on my skin, is it going to burn? If it gets in my eye, is it going to cause immediate damage to my eye? if I inhale it, is it going to make me pass out? So those are acute effects, and then also the chronic effects. If I'm exposed to this over and over a period of time, maybe I don't notice anything immediately, but maybe 20 years down the road, if I've used that product 150 times, am I more likely to get cancer or something like that?
That obviously takes a long time to determine. Chronic effects.
Yes. Yeah, it does. And that's part of why the registration process is so long.
Yeah, that makes sense.
So does it cause birth defects, affect the reproductive system? Remembering where to point my clicker. Cause genetic mutations, cause cancer, harm internal organs. And what happens if it's ingested or, if it's ingested or absorbed, if it gets on the skin, or, I inhale some of the mist from the spray, what happens to it in my body? Does it get absorbed and stay there, or does it get excreted and, sweat, urine, whatever? So, each one of these questions is going to cost, several $1 million to try and answer over, multiple years of studies. And then, so there's this whole process. So again, this is not some company whips something up, slaps a label on it, and it comes out to the shelf. Yes, sir.
I guess this is always an evolving process, like with the EPA or whatever. That is, for example, there's been a lot of news about how we're, there's that one trial in California, gentleman, is a landscaper, and was exposed to Roundup, and it was determined that his cancer was likely the result of exposure to Roundup over a long period of time. Was there like a loophole in this process, or was Roundup vetted earlier on in the evolution of this?
Okay, so that was my understanding is that was a jury trial.
Yeah.
And all the juries were internationally renowned. There was a soil scientist and a chemist and an agronomist. No, it was like teachers and
Right.
Police officers, and so that was a legal decision. So it was members of the general public doing their civic duty, trying to analyze and make a decision about a whole bunch of really complicated scientific evidence. And so I'm very passionate about science, and that's been my background for the last 20 years is, working for Extension is we take the research base from the university and carry it out to the people. And I have met so many of the great researchers at NC State who work so hard, to try and answer these kinds of questions. So, what was the question? So was there a loophole or was there a failure in the system? I think was kind of your question. And I would argue that no, that decision had nothing to do with science. That was, lawyers in a courtroom trying to convince. So.
Yeah, sorry to
No.
So something I think that is worth keeping in mind about a lot of these testing processes is that the way scientific research works, we can gather evidence and show what we think is going to happen in the vast majority of cases. Science does not work to prove a negative, though. It cannot prove that something will never happen. It can just say that given this preponderance of evidence, given what we know about the state of the field right now, we think that this is by far the most likely, and we think this is not going to cause it. You can't say it's never going to cause it in any case, and I think that most people hear that and get nervous and say, well, then you can't say anything. But actually, you can say that given the vast majority of cases, and I mean vast, and given the preponderance of evidence of everything we know, these things are being deemed safe under use conditions that they should be used under, and a lot of these products are not used the way they should be.
Let me just give you kind of a bottom line answer, and I don't want us to get too far into the weeds here, but that was an interesting. My belief, as I said at the beginning, is when pesticides are used judiciously and correctly, they are very, very safe. And I don't have any issue using glyphosate at all. And I think there's overwhelming evidence that when used according to the instructions and what the science shows us that it is safe. Do you feel like I've answered your question? Okay. Yeah. And Holly?
I just was wondering, is it okay, like I know that in Canada it's banned and in Europe. Is it okay to say that? Like, okay, it's not banned here, so maybe they assume.
What's
that
banned?
Roundup.
Glyphosate.
Well, and that goes back actually to, sorry, this was something yeah, we can talk about it.
Yeah, let's come back to that. But I think we're getting a little off track.
We can talk about it probably at the end. We might have a little bit of time.
Okay. So when we're looking at environmental effects, it's really important to remember that we're not getting this back in the bottle after it's been sprayed. Okay, so we better come up with a really good answer about what are the effects of that after it's been released. And again, the studies that go into this and the science, it does a really good job of answering these questions. And I think one of the kind of general public misconceptions or a common way of thinking is that, well, how many times have you heard, well, we used to consider this safe, but now we found out it's unsafe.
Seem like chlorine and DDT.
And so there's this kind of mindset that, well, we think it's safe now, but what about what happens? What are we going to learn later? It's a fair question, but you also have to remember that science has gotten way better at answering those questions. Okay, I mean we've got this whole foundation that we've built, all this evidence over time, and so these chemicals that we found that maybe these weren't such a good idea after all. We have all kinds of new ways of evaluating and testing. Our methods have just gotten so much better and more accurate and more thorough. So I think that's a good argument against that kind of mindset or misconception. But we do want to know the answer to those questions. So this is part of the testing that goes into that product development and that pesticide registration process. Is it going to have harmful effects in the environment? And there's a whole protocol for trying to get those answers. Is it going to leach into groundwater? That's a really important question because that's where a lot of people get their drinking water, like me, from the groundwater. What happens to that molecule after it's been released? What happens when it's exposed to sunlight or water or air? Does it break down into harmless inert ingredients, or does it change into something else that's toxic or whatever? So we got to try and answer those questions. And then, is it going to harm wildlife, birds, fish, beneficial insects? Again, we've got scientific protocols that are required by law that the manufacturers have to go through to try and answer these questions. And not only that, it's not like after this product has been put on the market, it's not like the research ends because universities are continuing to look at this, and you'll see as we go through this, we're continually trying to answer these questions and look for unintended effects. Really important question. does it leave unsafe residues on food? And this is what the research company that I work for, this was the bulk of the work they did. And so they would actually take the experimental product. I mean, we wouldn't, we would hire subcontractors on farms across the United States in different environmental conditions, and spray it on strawberries here and strawberries here, and strawberries in Texas and Florida and California and North Carolina, and harvest those strawberries once they were mature according to standard agricultural practices, ship them to a lab, and have those strawberries analyzed for residues, and that's all before it goes to market, right? So, and the answer to that question will help determine the rate that's applied and some other parameters that you'll see as we go through here. So again, really want to emphasize bottom line, pesticides are studied rigorously. The EPA reviews them carefully before approval, and they are also reviewed periodically. So the Environmental Protection Agency, and by the way, I want to emphasize that this is all based on a federal law. So it's not just some administrator at the EPA saying to the company, well, let's do your test this way. I mean, there's specific protocols based on law and regulations that they have to go through to answer these questions. And part of the law, or I don't know if it's a law or regulation, but the products have to go through a re-registration process every so many years. So, if there was a product, you might think, oh, well, gosh, malethion's been on the market for, I don't know, probably since at least the 1970s, and you think about how much science has advanced since then. So did we miss something with those old scientific methods? Well, maybe we did. So therefore, we have a requirement that products that are on the market, they have to go through re-registration on a specified interval. And so sometimes things get new restrictions based on that re-registration process, where they look back at the data and say, well, that data you did back in 1975 really didn't answer this question very well, so we need to do a new study. So there's that safeguard as well, and I think that's an important one. And then again, bottom line, pesticides are safe if used correctly and judiciously. All right, so we go through that whole registration process, and it leads to a very important, vitally important document, which is the label. And you'll hear us over and over again say, read the label, read the label. Don't forget to read the label, always read the label. But what we're really saying is read the instructions. And so the label not only includes, this nice graphically designed, colorful thing on the outside, but any printed material that's attached to that container is considered part of the label, part of the instructions. And so, anybody ever done this?
Thank you.
Ah.
Assembled furniture?
Yes.
Okay. Do you always pull out the instructions, or do you kind of start and see if you can figure it out, and then when you get to a stumbling point, I usually just jump in. I'm like, my dad was an engineer. I can figure this out. So, and you think about, okay, what was the process for developing those instructions? All right. Well, it was probably 3 engineers and a technical writer sitting in a room and, putting this, they've got the prototype and they're putting it together and they're all working together to write these instructions, right? And they finalize it, and, maybe it's somebody in another country who, English is not their first language, and so, you know, some of the syntax or the grammar may not be 100%. You know, that's the process, you know, your IKEA furniture or, you know, other consumer goods, the instructions may follow that scenario. But with the pesticide label, no, that's not how it works, okay? It's, I'm sure, reviewed by multiple scientists by the manufacturer, and then it's also carefully reviewed by the Environmental Protection Agency. So it's very specific. There's lots of information that are on that label that are required by law. And, you know, it's not like the person writing it gets to decide. You know, it's all based on the science as far as determining, okay, what's the rate that's going to do the job, what's the thing that you need to wear to protect yourself from exposure. All that's based on the science, and it's carefully reviewed. So there's a big difference. And then we've got to follow those instructions, and that's actually a law. And there actually is enforcement. Now, you know, it'd be pretty rare that you as a gardener would, you know, get fined for using a pesticide incorrectly. But if you're out spraying your lawn for chickweed on a windy day and it drifts over onto your neighbor's rose garden and causes damage, and you and your neighbor don't get along very well, that neighbor is within their rights to call the Department of Agriculture, the North Carolina Department of Agriculture, and they will send an inspector out, and that inspector does have the ability to, well, I think what they do is they document and then they submit it to a review board, and then that review board has the authority to issue a fine. And then you can also have, you know, liability if your neighbor decides to sue you. So, so we got to follow the instructions. And again, you know, instructions are written with great care and according to very specific guidelines. The consequences of not following them are a little bit more serious than if you didn't use the right bolt on the IPM furniture, right? So we got to follow those instructions. All right. And time for a break. So we'll stop there. How long is the break?
Just a half-hour break.
Half-hour break.
So knowing what you know about, you know, the research behind